Hello, my name is Ramiz Khalil, and this is my Lab 5 on the energy principle. So here's a brief overview. So the purpose of this lab is to observe a projectile's motion and to see if we can use the energy principle to predict its max height. In our experiment, we found that our models are actually very accurate at predicting the max height, and the fundamental physics principles that we're going to be applying are Newton's second law and the energy principle. So Newton's second law, the force of an object is equal to its mass times its acceleration. So F equals ma, basically saying more massive objects require more force to move. And then the energy principle is the system's change in energy is the sum of the work done by the surroundings and thermal energy exchange with the surroundings, which is delta E cis equals work surroundings plus Q. And then we have the gravitational potential energy, which is UG equals mgh. It's the mass of an object times the force of gravity and its height off the ground. So in the experiment, I had a rubber band ball that I threw in a projectile fashion, and the surroundings were the earth, so gravity and air resistance. For tracking the position, we used Tracker, and all of our computational models for our predictions were in GlowScript. So here's the initial conditions of the experiment. We have the mass of the rubber band ball as well as the initial position and the initial velocity. The initial velocity was found by doing the second velocity minus the first velocity over delta t, and the position was just found by observing where the ball was at the start of its trajectory. Our change in time was 0.0333. That's the frame rate of the video. We start at t equals 0, and of course you know what g is. So here's the GlowScript code inside of the while loop that we did. So we calculate net force, set Fnet equals Fgrav. We don't take into account drag here. And then we do velocity update, which is Newton's second law, position update, and then we calculate the gravity potential. And if the gravity potential is higher than our current highest gravity potential, then we obviously set our highest gravity potential to UG, and we set our new highest position to our current position. So here's our results. The max height for the real ball was 2.058 meters, and the max height for our simulated ball was 1.823 meters. So there is a margin there, but the trajectories look about the same. That margin can possibly be explained by tracker error, so maybe my calibration was off in tracker, or my initial conditions were wrong for the experiment. Maybe our velocity wasn't quite accurate. So discussion questions. What if we had thrown the ball on Mars? How would the maximum height of the projectile change according to the energy principle? Well, the gravitational potential energy equals mass times the force of gravity times height. So if g on Mars is weaker, that means the force of gravity would be weaker, meaning the max height of the projectile would be greater on Mars. And that is it. Thank you for watching.